Laura Lee, have you studied animal classification in school?
Nope.
Well, you know some animal classes, I assume. Like
yeah,
what?
like mammals, reptiles, amphibians.
Right. Okay, that's what you and I are going to do today. We're going to classify a whole group of animals, and they're all going to be live and hidden here in this room and over there.
Oh.
Okay? And you're going to have to identify them before we reveal what they are by looking at their characteristics.
Okay.
For example, they're all animals. Then there's a whole group.
No backbone.
Okay, then there are 4 here now that have different characteristics. In this first case,
Soft body and no limbs.
and underneath that yellow piece of paper is a picture and the words that identify the animal. But you can't reveal it until after you've actually identified the animal live here today, okay? Are you ready? Let's take that first one over there. It's over here in this thing. What could be under there?
Could be a snake, but a snake has a backbone.
Yeah, so
So it's probably a worm.
a worm. Aha. Is it a snake or a worm?
It's a worm.
It's a worm, an earthworm.
Yes.
Okay, you were correct. Let's go back and see on the chart. If underneath that picture is an animal with no backbone,
Soft body and no limbs.
which is then a
Worm.
Okay, you were correct. Next,
No backbone, soft body, and a shell.
and that's over here on the table underneath that gray box. What
Well-
could it be?
Could be a turtle.
A turtle? Does a turtle have a backbone or yes
don't
or no?
know.
You don't know. Well, then I guess you better uncover it very carefully.
And snails.
Yes, a snail. Does not have a backbone, soft body, and a shell, right? Okay, so you see if you agree with scientists when they classify.
No backbone, soft body, and a shell. It's a snail.
Next.
No backbone, 3-part body, and 3 pairs of legs.
Okay, and that's over here under that beaker, which is upside down. See it?
Yeah.
What could be under there?
I guess it's some kind of insect.
Why?
Well, because of the number of legs.
A number of legs, okay. Carefully, slowly. Okay.
Yep.
What kind of a...
Those are crickets.
The crickets, yes, and they're a class called
Insects.
insects, okay? See if you agree with the scientists who have said no backbone
Bone, 3-part body, and 3 pairs of legs.
is an
It's an
insect.
insect.
Okay, next.
No backbone, 2-part body, and 4 pairs of legs.
And that animal is underneath this pail. And another clue, it's at the other end of this string.
I don't know what it could be.
Well, then maybe you don't even going to take a guess, just lift the pail up?
Yeah.
Okay. Carefully, slowly.
Ew, gross. It's a tarantula.
How many legs?
1, 2, 3, 4 on each side.
4 on each side. And those 2 that look like legs in the front are palps that they use to investigate their environment.
Oh.
What kind of an animal is this?
Spider.
A spider. Okay. Here, you want to put the pail down on top of him? Can't go wandering around. Okay, let's see if you are correct.
No backbone, 2-part body, and 4 pairs of legs.
Right. You counted the 4 pairs. And what is it? A spider. Very good. Okay, now we're switching from no backbone to what?
Backbone, cold blood, and warm
Cold blood and warm blood. So first in the cold-blooded column,
It breathes underwater and lays eggs.
and the animal that does that is over here underneath this thing right here. What could it be?
Could be a fish.
Okay, slowly, carefully. You're correct. What kind of fish is it?
It's a goldfish.
A goldfish. All right.
Okay. Backbone, cold blood, breathes underwater and lays eggs.
All right. A
It's a
fish.
fish.
Very good. Next.
Backbone, cold blood, part of life in water and lays eggs.
And you'll find that animal under the tray over here.
Okay.
What could it be?
A frog.
What classification of animal is a frog?
An amphibian.
Amphibian.
Ew. Gross.
Well, you kids use that word gross all the time, but this time it happens to be quite a proper word because gross means big, right?
Right.
And it's a big what?
Toad.
A toad, yes. sort of a cousin to the frog, right?
Yeah.
And if you don't mind, I'll cover him up because I don't want him hopping around out here, okay? So go see if you were correct. You said frog, and it's...
Backbone, cold blood, part of life in water, and lays eggs. Says
You
frog.
were correct. We're both correct if it had said amphibian, right? Because they're
Right.
both amphibians. Next.
Cold blood, breathes air, and lays eggs.
Okay, and that animal is over there in the bread box. What do you think it is?
Probably a turtle.
Okay, go ahead, open the bread box. Here.
Here he is.
What classification of animal is this?
He's a reptile.
Yeah. So it could have been a snake in there, right?
Yeah, I'm glad it wasn't.
Well, snakes are interesting animals too, just like turtles. Okay, so put it back in so he won't wander around the room. Okay. Backbone.
Cold blood, breathes air, and lays eggs.
Okay,
It's a turtle.
very good.
Okay.
Next.
Backbone, warm blood, and lays eggs.
Well, this is the first time we're in the warm-blooded column, right?
Right.
And lays eggs. And you'll find those animals underneath this cloth.
Could be pretty big.
Dinosaur?
No, not that big.
I'll give you another clue. Feathers.
Oh, birds.
You know what? The only animal that has feathers
Yep.
is the bird. Right.
They're
Two of them,
pretty.
as a matter of fact. Yeah.
What kind are they?
They're peking robins.
Neat.
Yeah, aren't they neat? That's a good word for them, neat. Okay, so we have one more classification. If you got this one correct, which was backbone
Warm blood,
and lays eggs. Okay.
It's a bird.
Bird, correct. Now, notice, by the way, that we've finished with all the no backbones. We finished with all the backbones, warm blood, except for that one. And I told you all the animals were here today live.
Right.
And we've run out of containers.
Well, where could it be?
Uncover the picture.
That's me.
Yes. What kind of an animal are you?
I'm a mammal.
A mammal, right.
I've seen those before in my uncle's room.
Yeah, look red like this, had red liquid
Yeah,
in the bottom.
exactly the
With
same.
the yellow hat on.
Yep.
Well, these dipping birds are kind of popular because they move back and forth all the time in a sort of mysterious way, so they're often used in novelty shops. You know what makes them dip?
No, not really.
Well, see if I can explain it. First of all, see that red liquid at the inside?
Yes.
That's a liquid that boils at a very low temperature, which means its vapor expands very easily at relatively low temperature. In fact, somewhat like the liquid that are in these two spheres connected by the tube. Put your hand around that one.
Sort of boiling.
Yeah, well, it looks like it. Actually, it's the vapor expanding up here. And sometimes these are sold as love meters or something like that. Because theoretically, we could put our hands around there and see who's, the heat of the hand makes it boil the most. So here's another version, but a simpler one. Here, hold on to that.
Looks like a Christmas tree ornament.
All right. That's how Christmas tree ornaments work. See, the vapor down below is bubbling up through here and making it look like it's boiling.
I
See, now,
see.
the same thing is happening with the bird. Let me take this one, but I've taken the tail off it so you can see. Okay,
Just
now,
dipped.
now the liquid is down here in the bottom, see?
Yes.
But watch, see how the red one is climbing? In fact, put your fingers around the bulb and you can make it go up a little faster. Watch. See it?
Oh,
Okay.
yeah.
Now what happens when the liquid gets up in the head?
Dips.
It dips down. And the important thing is that frees the tube. See how the end of the tube is now free here?
Yes.
And it's important that you have a stop so that it doesn't tip all the way. So what you, in effect, are doing is allowing the liquid to run back down into the bottom. And when it gets down into the bottom, what's going to happen then to the weight?
It's going
It's
to
going to be
heavy
heavier in the
down.
bottom, so it'll finally come back up like this.
Yeah, and then
Now-
the whole process is repeated.
Well, the one thing that you have to keep in mind is that it dips into the water. Put your finger up here with the head. Feel that? It's sort of a felt-like stuff on there?
Yeah.
Well, when it dips into the water flows up and wets this thing, and as the water evaporates into the room, well, it cools the head off, and that's what makes the liquid go up.
It's interesting.
Yeah. So it dips down, gets the head wet, then it begins, and then it comes back up this way. Gradually, as this evaporates, it cools off, heats this up, and again the whole process starts all over again. So the energy to make it work is really the heat in the room.
Yeah.
And most people don't realize it. But now you know what makes the dipping bird dip. Mice and rats are used by scientists as test animals because they can be a substitute for people in many different kinds of experiments. They're also small, easy to breed, raise, test, and feed. Unfortunately, mice can't substitute for cows in nutrition tests because cows are ruminants, animals with 4 stomachs. Dr. Robert Cowan of Pennsylvania State University has found a laboratory animal that can be a stand-in for cows and sheep and similar animals, a miniature antelope called a blue duiker. Duiker is Dutch for diver because in South Africa, the antelope dives under bushes rather than jumping over them. Dr. Cowan brought back 18 blue duikers from Africa. He keeps them in isolation to protect them from disease. They're the smallest of all antelopes. The adults weigh about 9 pounds, about as much as a medium-sized dog. Since they eat only 1/20th of what larger ruminants eat, they're less expensive to feed. Because they eat so much less, enough food can be grown in a greenhouse for a variety of nutrition experiments. Developing new kinds of feed for large commercial herds of cattle and sheep will now be faster and more practical because scientists who study animal nutrition have their own efficient laboratory test animal, the world's smallest antelope, the blue duiker. I assume you've stepped on a scale like this to find out how much you weigh, right?
Yes.
How much do you weigh?
63.
Okay, what happens when you step on the scale?
The 0 moves to a different number.
Okay, it moves down, you know.
Yes.
So I've got this all set so that we can take it apart to see what goes on inside the bathroom scale.
Okay.
I think you might be surprised.
Well, I thought there was like a big spring or
Yeah,
something.
as a matter of fact, it's quite a small spring. There it is right there, right?
Oh,
now,
it's
and down
peeling,
here
huh?
is the thing that zeroes it, so move that once and you'll see what happens.
Okay.
See?
It's moving the 0.
Right, now move it back so you can center it up about right like that.
Right there?
Okay, now I'll take the dial off and you'll get a good look at what happens inside.
There's another spring.
Mm-hmm. Well, that spring sort of controls this arm. So here's a pivot point. When you put pressure here by standing on it, see what it pushes down on that spring, and that moves the dial over here. All right.
So that when your body weight comes on to this,
Right.
then
It moves the dial. Okay. So that's what's inside the bathroom scale. Now I took it apart. Do you think you can put it back together?
I'll try.
Okay. First that. You can line up the 0. Okay. Very good. Next.
There.
Think you got it?
And then
Okay,
there.
try it. See if you put pressure on it once. Sure enough, very good. Andrew, I have 2 mysterious liquids in 2 ordinary glasses.
Yeah.
See, and they're connected by 2 tubes. And the 2 tubes come up here and branch out, and they go all into 1 tube, and that 1 tube leads around over to here. So what I would like you to do is to suck gently on the tube and watch what happens to the orange liquid and the green liquid. Okay? Okay, what happened?
Well, the orange liquid went higher than the green liquid.
Yes. I told you they were mysterious liquids.
Yeah.
Why? Here's another clue. Now try blowing gently into the tube and watch what happens. What happened?
Well, this one bubbled, but this one
Didn't.
didn't.
All right. Okay, now let's see if I can give you some clues that will help you discover what those mysterious liquids are. Here are 2 glasses, right? Yeah. Here are 2 hydrometers. Do you know what a hydrometer is? Hydro means water, and meter means to measure.
Yeah.
These are gadgets that measure the density of liquids. Okay, here, put them in the orange one.
Okay.
Okay, now notice where they float? Almost all the way down.
Yeah.
Now take one of them out of there and put it in here.
Okay. Well, this one, sir. Well, this one
Yeah.
floats higher
Why?
than this one.
Think of the density, the sort of thickness of the water. If one, or the liquid, if one were more dense than the other, which one would the hydrometer float highest in?
Well, this one,
Right.
it looks thicker.
Because it would be pushing up more, right?
Yeah.
Okay. Now notice what the labels are.
The green one's salt water,
Right.
and the orange one's water.
Okay, that's the same as these over here. Now, could you explain to me why they acted so mysteriously? First of all, suck on it again, gently, and watch what happens. Now that you know which is which down here, explain.
Well, this is the salt water, and the orange one is the
Plain water.
plain water. Well,
So
maybe,
why would the orange one go higher?
well, maybe because this one isn't as dense as this one.
Well, think of what you're doing. When you suck on the tube, you're taking out some of the air here. So outside air is going to push down and force the liquids up. So the pressure is going to be equal. So this one is denser, so it doesn't have to be as high to be equal to this one, right?
Yeah.
You get the idea?
Yeah.
Okay. What happens when you blow?
No.
Think now, think.
Well, when you blow, this one bubbles and that one doesn't.
Why?
I think it's because, well, okay, this one's dense.
This one's denser, so you have to blow harder on that
Yeah.
one, right? So instead of coming out of there, the air comes out of here.
Yeah.
Well, congratulations, Andrew. You solved the mystery of the two liquids.
Okay.
Brian, if you tie a string onto a fork like that and hold it up, and then with another thing, can be another fork, tap it like that, it makes a sound, doesn't it?
Oh, neat.
Yeah.
It's not very
But it's
loud,
not very loud.
No.
Well, actually, not only is the air around the fork vibrating, but some vibrations are being sent up this string. So if you hold the string in the middle of your ear, try it once, and then I'll wrap it, I think you'll hear a louder sound. Go ahead.
yeah.
Hold it like. Now lean forward so that it's not touching your shirt. And now listen.
Oh, that's weird.
Weird.
Yeah.
Doesn't it really sound like a great big church bell?
Yeah.
Okay.
And it's
Now
really loud.
So if you want to do that at home, just try a spoon, try a knife, and try a fork on the end of a string, then wrap it against something while you're holding it in your ear. In order to hear three at once, here's what you do.
Oh.
Here, you want to take that and hold it?
Wow.
Okay, back up there a little bit so that you can listen in the cone while I wrap the three forks.
Oh, that is so weird.
So you can make you got some paper to make a cone, right?
Yeah.
You got some string,
Uh-huh.
and you got some forks at home?
Yeah.
Good, you're all set to make forks into church bells. You've watched alligators at the zoo, but you've probably never seen a man in the water with the alligators. Dr. Walter Offenberg of the Florida State Museum and Ken Vliet of the University of Florida get into the water with alligators to study their mating behavior. In the beginning, they observed the more than 150 animals in the large pond at the museum from the boardwalk above the pond. They and their volunteers spent hours watching the behavior of alligators during the mating season, which begins in April. When they analyzed their observations with a computer, they were convinced that the alligators had become accustomed to human visitors and were carrying on their mating rituals as they would in the wild. Adult alligators are large, powerful animals, very capable of injuring one another. Courtship rituals between individuals are important in reducing aggression. After a series of experiments, the scientists learned that it was safe to actually go into the water with the alligators during the mating season. They even mounted an alligator head on a pole and mimicked the motions and sounds of an alligator during courtship. They were not entirely successful at getting an appropriate response from their subjects. But they did discover that many courtship patterns consists of slight movements, raising a head above the water a little, or a small swimming move. Studying the behavior of an endangered species is a first step in helping them on the road to recovery. This research could shed new light on the once endangered reptile that is now on the road to a comeback, the American alligator.
This thing's pretty heavy.
Yeah, that's because it's solid iron. And what I'd like you to do is fill it full of water. Okay, here's the water.
Okay. To the very top?
Right, the very top.
Okay.
That's water that I boiled to drive out all the air. Okay.
That's enough?
Make sure there's water all the way to the very top. Okay, good. Here, now put the top on. And with the pliers here, now make sure it's good and tight. Here, I'll hold it for you. Okay, good. Now, at the other end of this rope is a hook. I want you to hook this onto the hook.
Okay.
Okay, see the hook there?
Yep.
Okay. Now notice that it's positioned right above this stuff.
Yeah. What is it?
Well, looks like boiling water, but it's actually alcohol with dry ice in. So there's the tongs. Put some more pieces of dry ice in there, because that's a very cold bath. And what we're going to do is lower this called an ice bomb, into the cold bath to freeze the water that's inside. Okay? One more piece to do it. And the reason it's on this long rope is that we want to back away to be at a safe distance. So you go back over there to the table and slowly lower the ice bomb into the bath. Okay, now the ice bomb was so hot that it's boiling the liquid in there. So don't take your eyes off it, because what do you think is going to happen?
It's going to explode.
Why?
Well, you called it a bomb, so...
Right, it's a bomb. As a matter of fact, what's happening is the water that we put in the bomb is now changing to ice. And you know what happens when water freezes?
It expands.
Right. Have you ever done that?
Yeah, I put a bottle of pop in the freezer. Forgot about it, and a couple hours later, there's
Don't
frozen
take your eye
pop
off.
all over the freezer.
Right. Okay, well now the same thing happens outside the freezer. In a mountain, for example, water flows into a crack in a rock, and then in the winter it freezes and actually splits the rock apart. And if you'll notice at the bottom of the mountain,
Whoa!
oh, take a look at that. At the bottom of the mountain are little tiny pieces of rock that have been broken up from the big piece. So here, go around over there. See, can you take the tongs and reach in there and get one? Here, put it down right over here. Oh, there, you got a whole bunch. Great.
The majority of it.
Yeah. In fact, I think you got it all, haven't you?
No, there's one more piece, I think.
Well, at least you get the general idea that when water freezes, it expands with considerable force, not only breaking a bomb apart, but tearing down whole mountains.
Wow.